Okay, guys, so if we pick up where we left off yesterday, we were just finishing dividing, and we were talking about the domain, right? So we had done our factoring. I showed you how you could kind of guess and check. I also went through product of AC over here. And then we were talking about domain. And I was trying to get you guys to remember back at end of last semester, November, December, we were talking about rational functions and a fraction. When can a fraction not exist? When there is 0 in the denominator. And so the idea here is what would make my denominator 0? So if you recall from Unit 4, set each part of the denominator equal to 0. So 2x plus 1 equals 0, x minus 7 equals 0. We come up with these values that x cannot be. So on a situation like this, we're adding, subtracting, multiplying. My domain was pretty much all real numbers. However, here, my domain is going to be all real numbers except x cannot be -1/2 and x cannot be 7. So all real numbers except x equals -1/2 and 7 because those make my denominator equal to 0. Okay? So that's going to be one of your, things you have to watch for on domain. Now, I am pretty sure you see a product of AC in homework. So whether you use product of AC or whether you try and guess it, guess and check here based on surrounding clues, that works as well. Unless you have questions, shall we talk about B? Okay, so B, be careful, give yourself room. For some reason, I thought I could squeeze in 2 here. It's kind of doable, but it's a little tough. Okay, so we're going to perform the function operation, find the domain. Again, we are looking for f of g, so remember that is doing f of x divided by g of x. And so if we set this up, x squared minus 3x minus 18 over x plus 3. So I get to leave my answer like this. No, most likely what's going to happen? That numerator probably factors and it probably cancels with the denominator. So x squared minus 3x minus 18. Good news here. Can we just do some basic factoring here? X squared is going to break up into x and x. I need numbers that multiply to be -18 and add to be -3. What numbers can you give me? Okay. -6, +3. Denominator was already x plus 3, and what just happens? Yeah. X plus 3 can cancel with x plus 3. What does that make my answer here? Yeah, and it's x minus 6 over 1, which is just x minus 6. So just beware, our previous answer was 1 over the factor, but that's because that extra factor was in the denominator. Here it's in the numerator. And domain. Thoughts on the domain here? Where's our problem going to happen at? The denominator. And I don't have a denominator in my answer, but there was a denominator, yes? X plus 3 cannot equal 0. So when would x plus 3 equal 0? X equals -3. So all of that to say, my domain is going to be everything except x equals -3. So when you go to multiple choice pick your domain, this time I'm not looking for the one that says all real numbers. I'm looking for the one that's all real numbers except x equals -3. Okay. B is very similar. We're trying to find f over g. It's f of x divided by g of x. So this time it is x minus 3 divided by x squared minus x minus 6. X minus 3 can stay on top. The denominator is probably going to factor 2 parentheses, x and x. What kind of numbers are going to multiply to be negative 6 and add to be negative 1? Negative 3, positive 2. And what just so happens? We have a factor in common that cancels again, yes. Okay, so x minus 3's will cancel. What kind of answer do I have? This one's a fraction, isn't it? X plus 2 is in the denominator, and the numerator, if all else cancels, there's a 1 left. So 1 over x plus 2. Domain? Okay, we're back to having 2 exceptions here, right? And it doesn't matter just what's in your answer in the denominator. It matters anything that ever was in the denominator. So here, x minus 3, and here, x plus 2. So x won't equal 3. X won't equal negative 2. So my domain is all reals except x equals 3 and negative 2. Okay, we've added, we've subtracted, we've multiplied, we've divided. The backside takes us into compositions of functions. So this is where we get to talk about f of g of x and g of f of x, okay, where we are putting functions into functions, okay, we are composing 2 functions together. So at the top, we're going to just look at, what does it mean to do f of g of x or g of f of x? At the bottom, we'll look at our function compositions. I don't know if you remember me yesterday, I mentioned Fogg and Goff. We'll talk about what those mean. So, as with all the problems today, keep in mind, f and g are ever changing, right? Every problem, you've got a new f of x, a new g of x. So, don't ever assume that those are going to stay the same. But the idea here, as we look at A, find the value of f of g of 3. When you see parentheses, our job is usually to start inside the parentheses, right? So the more you can start inside, the better. And so that means here, in this case, we're going to find g of 3. So like this first example, we have a number in here. So we're going to have some examples today where there's numbers you're plugging in, and some examples where there's not numbers to plug in, we just leave it as x. Okay? When you see a number, start inside. How do we find g of 3? So what is my g function? G of x equals x plus 1. So if we're doing g of 3, every place I see n x, I'm going to replace it with 3. So if the function for g is x plus 1, instead of doing x plus 1, I'm going to do 3 plus 1. So g of 3 means I'm going to do 3 plus 1, because g tells me to do x plus 1, but x is 3. And 3 plus 1 is 4. That's the inside part. Are we okay with the inside part? Now, keep in mind, I'm not done with the whole problem, because what have I not given any attention to yet? There's an F on the outside, isn't there? So on the inside, I did the inside first. I found G of 3. So I put 3 into G. I got that answer. Now, my inside is a 4. And what am I going to put the 4 into? We're going to put it into F because we're trying to find F of 4. So now I'm going to go to my F equation. Every place I see an X, I'm going to replace it with 4. So what does my F equation say to do? It says to do X squared. Except I'm not going to do X squared, I'm going to do 4 squared. And 4 squared is 16. Okay. So when there's numbers, plug the number into G, get that answer, and then plug it into F. Okay. We'll come back. We'll do more numbers, okay? I'm going to take a break from numbers for a moment, though. And we're going to talk about, okay, what if there isn't numbers? So how do I find a rule for F of G of X? And the idea here is that we're going to take whatever is inside, so in this case, G of X, and we're going to plug G of X in to F of X. So whatever is inside, which is G of X, we're going to plug it into F of X. Now, start by telling me, what is G of X? According to my rules, G of X is X plus 1, yes? So I'm going to take that, and I'm going to plug it in to F. So when I look at F, every place I see an X, I'm not going to make it X anymore, I'm going to make it X plus 1. So every place I see an X, I'm replacing it with X plus 1. So what is my F function? F is X squared, but what am I replacing X with? X plus 1. So it was taking X and squaring it. Now I'm going to take, because I'm taking whatever I need to and squaring it. And so that inside piece is X plus 1. Okay. In my answer key, I have this squared out. Would Savas let you leave it like this? Probably not with what we're doing today. Some days I might, but probably not. What do I mean squaring this out? If it's X plus 1 quantity squared, what's that mean? X plus 1 times X plus 1. So square that out. X times X is X squared. X times 1 is 1X. How fancy can we be? And what's 1 times X? 1X. What's 1X and 1X? 2X. And then last, 1 times 1 is plus 1. And so this would end up at X squared plus 2X plus 1. Notice my final answer here still has X's in it. When you're finding F of G of X or G of F of X, your answer is going to still have X's in it. Questions there? Okay. Let's try the other way. And as I said, I've got lots of practice. This whole back page is practice today of this type of stuff. And I think the more you see it, the more it'll start to come together for you. Now, realize this one, we're doing the opposite. And it does matter. Okay? So here it's G of F of X, meaning I'm going to take F and put F into G. So what is F? F is X squared, right? So this means if F is X squared, I'm going to take X squared and put it into G. What does my rule for G say to do? My rule for G says to take X and add 1. What am I going to take in place of x? X squared. Okay, so I'm going to take whatever it is and add 1. Except in this case, it is x squared. What is x squared plus 1? X squared plus 1. Okay. Okay. B, if you're ready. New f and a new g function. And on A, we're asked to find g of f of 2. Lots of parentheses. I'm always going to say to start inside. So what does f of 2 mean to you? We're taking 2 and plugging it into f. What's the rule for f? The rule for f is 2x minus 1. So my rule for f is 2 times something minus 1. What's the something I'm putting in there? Putting in the 2 in there, right? 2 times 2 minus 1 is 3. 4 minus 1 is 3. Now, as tempting as it is to think, okay, I've done my math, 3 is my answer, don't. Keep going, because we have not touched the g. And g of 3 says what? The rule for g says 3x, 3 times whatever your input is. What's my new input? 3. So we're going to do 3 times something. In this case, it's 3 times 3. And 3 times 3 is 9. Okay. Personally, I feel like the numbers are probably a little bit easier than when you have to leave x's, but I don't know. You may disagree. Okay, B. F of g of x. Okay, what was I saying earlier? Start inside. We're going to take our inside of g and put it into f. What is g? The function is 3x, right? So my inside function is 3x. What am I doing with that 3? I'm going to plug it into f. Now, what's my rule for f? 2x minus 1. So it's 2 times something minus 1. Does that make sense how I'm doing that? I'm trying to give you guys ideas to help you think this through. So 2 times something. What's the something I'm putting in here? 3x. What is 2 times 3x minus 1? Yeah. 2 times 3x is 6x. And 6x minus 1 is 6x minus 1. G of f of x now. Reverse it. So what is f? According to the given rule, f is 2x minus 1. And that is going to go into g. So my new input is 2x minus 1. What am I inputting that 2x minus 1 into? Not f, but g. G says to do 3 times x. What am I putting in there? Yeah, it's a 2x minus 1. Now, be careful. What is 3 times 2x minus 1? Take that 3 and you need to distribute. So when we distribute 3 times 2x minus 1, it's going to be 6x minus 3. It's important to notice f of g of x and g of f of x are not the same, are they? Okay, same thing up there. F of g of x and g of f of x, not the same. It is very, very rare that they are the same, and we'll talk about that in the next lesson. Most of the time, they're going to be different, so you need to expect that. Okay, so that's a little bit of introduction into composing functions, putting one function within the other. Now, the bottom of the page, in all honesty, we're pretty much going to be doing the same thing. We're talking about composite functions, and if you read there, it says composite functions are the result of applying the rule for one function f to the rule of another function g. The new rule is denoted as, you'll notice it's f, there's that little circle, and then g. That's not a multiplication dot. If it was a multiplication dot, it would be filled in. That's what's called a composition circle. And it indicates f composed with g. Now, this is where I get fog from because it looks like FOG, fog. Okay, that's just a fun little way to remember it. But so f composed with g is equivalent to doing f of g of x. We were just doing f of g of x up top, weren't we? And so when we do f composed with g on the bottom, first thing I'm going to do is rewrite that as, okay, we're doing f of g of x. If you reverse it instead and it's what I call GOF, g composed with f, then I will always go ahead and rewrite that as g of f of x. Okay, so be familiar here with these function compositions. And if I say FOG or GOF or whatever other abbreviation we come up with, that's what it means. So you'll notice down there it says the operation symbol, that little circle, forms a composite function, is called a composition of functions. Again, as I said, we're going to change it out of this form, or we're going to do exactly what we're doing up here. I've got some more variable practice down below. I've got some more number practice. And I think we can get through all this. We should be able to. I feel like we're running quicker than this morning. So on A, they tell me f, I'm given a g. We're asked to find f composed with g of x and g composed with f of x. So, didn't quite leave enough room here, but we're going to make it work. If we're being asked for f composed with g of x, the first thing I'm always going to do when I see that composition circle is I'm going to transform this. And so instead of f composed with g of x, my brain's going to say, okay, that means it really wants me to do f of g of x. Okay. Start with the inside, just like up above. What is g? 2x minus 5. So that means I'm going to have f of (2x minus 5). So I'm going to take 2x minus 5. That's my new input. And where am I going to put that into? I'm going to put it into f. Every place I see an x, x is going to become 2x minus 5. So f says to do the square root of something plus 7. What is it I'm putting in place of x? 2x minus 5. So my square root of something plus 7 is the square root of 2x minus 5 plus 7. Do clean that up. Don't leave that answer. 2x minus 5 plus 7 is going to clean up to be 2x plus 2. You do get to leave it like that. We can't go any farther than that. Okay, so these functions are a little bit more involved down here, but it's still doing the same thing we did up above. That was FOG, as I affectionately refer to it. F composed of g of x. Now, we need to find GOF. G composed with F. Which means I'm going to rewrite this as G of F of X. So I'm going to replace my insides. G of, what is F? F is square root of x plus 7, right? My insides here is F, which is square root of x plus 7. Square root of x plus 7 is going to be put into G. What's the G? What's the rule for G say? 2 times something minus 5. So I'm going to do 2 times something minus 5. What is that something I'm putting in? Yeah. Square root of x plus 7. What is 2 times square root of x plus 7 and then minus 5? Yeah, it's that. 2 square root of x plus 7 minus 5. Notice, FOG and GOF do not produce the same answers in most cases. There's some similarities, but they're definitely different. Okay. Let's practice one more set of f of g of x to g of f of x, and then we'll go practice some numbers. So B, given an f and a g. Now we're going to find f composed with g of x. Are you at the point you can stay a little bit ahead of me? It's my hope. Try and stay a little bit ahead of me. Might get stuck here. It's worth a try. So f composed with g of x. First thing I'm always rewriting. F composed with g of x. F of g of x. Let's replace the insides. What are my insides? Instead of g, we're going to put in 4 minus x, right? So 4 minus x is my new input. We're going into f. Every place I see an x, I'm replacing with 4 minus x. Now, what's that mean in this case? Yeah, we're replacing x twice. It's supposed to be something squared plus something plus 2. Does that make sense if I do that? It's x squared plus x plus 2. So something squared plus something plus 2. What is my something I'm putting in? Well, that is the 4 minus x. I don't know what I was thinking with my spacing on this one. This one needs a little bit more space, really, but unfortunately, Savas is not going to let you leave this. They're going to have you work this out. How do we do 4 minus x squared? It's 4 minus x times 4 minus x, right? Okay. So FOIL it out. 4 times 4 is 16. 4 times minus x is minus 4x. Minus x times 4 is minus 4x. Minus x times minus x plus x squared. If I clean that up, minus 4x is going to be 16 minus 8x plus x squared. So this 4 minus x quantity squared is 16 minus 8x plus x squared. Plus, we still have the plus 4, minus x, and plus 2. Yes?
Would it make a difference if instead of keeping it as 16 minus 8x plus x squared, we switched it to where x squared would be like 5 minus 8x plus 6?
Yep. As long as you keep your signs correct, you're okay. Is it bugging you having the x squared at the back?
No, I worked ahead and I did it that way.
Nope, doesn't make a difference at all. As long as you keep signs correct, you can reorder all you want. So, okay. As we put pieces together, I think I only have the 1x squared, don't I? So we have the x squared. In terms of x's, I see minus 8x and minus 1x, which is minus 9x. In terms of constants, 16 and 4 is 20, plus 2 is 22. That one took a little more work. Okay, let's finish this one off here, and then we'll do a quick look at some numbers. Goss, G composed with F is G of f of x, which means G of f. What am I replacing f with? Yeah, f is going to be that x squared plus x plus 2. So we're going to take that whole piece and put it into G. What does the rule for G say to do? 4 minus whatever your input is, which in this case, that means it's going to be 4 minus x squared plus x plus 2. I will say be careful here, right? We are subtracting everything in this parentheses, right? So 4 is going to be 4 minus, what's 4 go with? 2. 4 minus 2 is 2, if you want to put that first, or you can put it at the end. There's also going to be a minus x squared, because you're subtracting x squared. And there's going to be a minus, what else am I subtracting? X. Probably not the ideal way to write the answer. But 2 minus x squared minus x. Or if you prefer, if you don't like that order, it's what? Negative x squared minus x plus 2. But unless Savas has a specific situation, I don't think they're going to matter which way you put it in. Okay. Took a little while to get through that than I would have thought, but we're going to practice some numbers. I think the numbers go a little quicker, in my opinion. We're still doing the same type thing, though. Start on the inside, work your way out. Now, instead of G and F, it's G and H. So I guess we're going to find Ga and Hog. Go and Hog? I don't know. So G composed with H of 5. So realize G composed with H of 5 is going to be G of H of 5. That's my common rewrite. Start where? We're going to start inside, yes? What does H of 5 tell me to do? It says to do something plus 1, right? What's my something in this case? 5. So 5 plus 1 is 6. God, love it when it's easy math at least. So now my H of 5 turned into a 6. So I took 5 in, put it into H. It was 5 plus 1 is 6. Now, what does the rule for G tell us to do? Take something and cube it. So what are we? We're taking something and cube it. What is that? That's 6. And so 6 cubed is 216, I believe. Right? Okay. Okay. Hog of -3? Or, more properly said, H composed with G of -3. So H of G of -3. Start on the negative. Start on the inside. Take the -3 and put it where? Into G. What's G tell me to do? Take the number and cube it. So -3 to the third is -27. And then, what have I not done yet? H. So now my new insides is -27. Take -27 and put it into H. What's the rule for H? The number plus 1. So -27 plus 1 is -26. Getting a little easier? Maybe I did too much practice today. I don't know, but it is what it is. Okay. Fog of -2 real quick. F of G of -2. Start inside. I'm running out of time, I'm realizing. Sorry. G of -2. G says to do number -5. So -2 minus 5, which is -7. So now, my new inside is -7. What's F tell me? What's the F rule say?
-7.
Square the number and add 1. -7 squared is 49, plus 1 is 50. And last one, Goth of 4 means G of F of 4. Start inside. What's F of 4? The F rule says square the number, add 1. 4 squared plus 1 is going to be 17. So now, it's G of 17. What's my G rule say? The number minus 5. And 17 minus 5 is 12. Okay, guys. Sorry, I sped up those last two. Your homework. It's available in Savas. Lesson 5.5. I don't know if you've looked at it yet or not, but plan to get it done for tomorrow. Okay? Tried to give you lots of practice. Hopefully it helped. If not, bring back questions tomorrow. Okay?